Chapter 7, Section 2 is properties of exponential functions, how we can use a calculator to evaluate the natural base exponential function. The natural base exponential function is a function whose base is e, like the letter e, and there is a button on the calculator for that. It's most useful when you have continuous growth or decay, but it does have the same properties as other exponential functions that we've been graphing. So example 1, you're just using the calculator. Take a second, type all of them in. I do want to point out that it does say to 4 decimal places, so make sure you have 4 and you round appropriately. Continuously compounded events. Continuously compounded events are exponential functions whose base is e, and they're found a little differently because continuously compounded events occur every instant, and you build interest on interest, not just your principal. So the formula for this, I always remember it saying PERT, that's the principal times e raised to the RT power. Big A is the amount of the account at whatever time you're dealing with, which is what we're used to, and T is the time of years. P is the principal. In the section before, we called that a lowercase a, but it's the same idea. And R is still the annual interest rate. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. That compounded continuously means we need to use the formula that has P times e to the RT. So $3,000 is what you put in, that's your principal. It says I have a rate of 0.5 or 5%, which is 0.05, and they want to know how much will be in the account when you enter high school 4 years later. So all you need to do is type that into the calculator the way that you see it. You should have $3,664.21. Example 3, you and your spouse put $2,000 into an account upon your marriage. The account pays an annual interest rate of 5.1% compounded continuously, means use the PERT formula. We want to know how much money you'll have on your 3-year anniversary. So the principal amount is $2,000, and the rate is 5.1, which is 0.51, and we're looking for a time of 3. $2,330.65. A student wants to save $8,000 for college in 5 years. How much should be put into an account that pays 5.2% annual interest compounded continuously? So still start with your A of T. Now, they say they want to save $8,000. That's not what they start with, which means $8,000 actually goes on the left side of this one. It pays 5.2% interest, so 0.52 for that. And I know that it's in 5 years. So now, this one's a little different because we're actually solving for P. Take a second and find that quantity in the calculator. Make sure you have a bunch of decimal places. Oops, that's a 9. In order to solve this, like you did in Algebra 1, just divide both sides by 1.29693. So the principal on this account was $6,168.41.